Okay, well, now that we've got an audience, I will start. So, hello, I'm Yusuf. I'm a software engineer at the developer advocacy team for ARM. So, developer advocacy, what we want to do is to enable developers to make the most of any ARM technology. At GDC is about games, so this is enabling developers to, well, the tagline here, build better games faster on ARM. So, my focus is on AI, really, and game developers. There's a big push for AI in games because it's a nice technology, it enables a lot of things. So some of the things we've done, so this is something we had last year, Koki, who's speaking next. This is ML agents. All these individual rabbits are controlled by a NPC AI model. We have depth estimation. That's very good for AR applications because to first work out where all your edges are, where all your geometry is, first need to calculate how far everything is from the camera, and having a nice performant model, AI models can help with there. And then there's this sort of image enhancement thing, which, you know, you've had a Zoom call, someone's got a black background, can't really see them. It's useful for that kind of thing. And I'm going to use this as a motivating example for what I'm going to talk about, which is, we all talk about, you want to run AI models, you want to do this really cool thing, but no one really tells you how, what are the problems, what are all the pitfalls that you need to deal with. So this talk's going to be going through some of those, using this sort of image enhancement idea as an example. So, as I said, it's becoming more prevalent, and this talk is about getting you to be able to use all these AI models easily and integrate them, because it's unclear, a lot of different resources that you may come across need, people saying use this, becomes very unclear. So, and we at ARM, we do a lot of these things, and we encounter these problems all the time. So, with that in mind, first you've got to find a model. Models are task specific in general. Well, we're not all ChatGPT, OpenAI, running a massive multimodal model. And when you find a model, well, you've got to consider what task you're doing, want the model for, get some very nice models, very specific tasks. Several examples around here, but there are some considerations you've got to do. The model size is a key one. We're on mobile, quite a constraint in resources. So we kind of want to reduce the model size because this reduces the compute cost. The availability of the model, some models are sort of hard to get. Sometimes maybe there's a licensing issue. Maybe the model's there, but it comes untrained, in which case, do you really want to spend all the resources training it? So that's another consideration you need to take into account. And model format. Is this just some researcher's PyTorch GitHub repo? Is it served through something like Hugging Face? Is it a TF-Lite file? What is it? And how are you going to use that? So some useful resources for finding these models. Hugging Face is a nice big repository. They've got Optimum CLI, which is a nice tool you can use to download these models, get into a format. ONNX format's a pretty standard format for these things. I mentioned PyTorch Hub and GitHub. PyTorch models, I said before, they do exist. PyTorch internally has a way to export to ONNX. Very useful, I've found. And Papers with Code is another sort of place, latest research papers, and then links to the implementations of those. So very useful if you see something released as a paper, but where do you get it? So that was a slight skip. So we find the model. For this case, we wanted to do image enhancement. We identified 53 models that were there, and 35 just really couldn't be used. So some of them had licensing restrictions, some of them ran or had dependencies. We're targeting mobile here, obviously. So things that are only, the dependencies only being available for desktop, that's not good for our use case. So that's another consideration, and some of them they're untrained, can't use that. Some of the other models, maybe the quality wasn't enough. eventually we sort of settled on this model from a paper we found. It doesn't have a nice name, annoyingly, but there is the paper. And that was one of these cases where we had a PyTorch model, used the PyTorch internal ONNX converter to get a nice ONNX file that we can port to a lot of different places. Right, but once you've found your model, you need to run the model. So you run it through an inference engine. There are several inference engines. Unity Centis is one that's integrated within Unity, so if you use that, that's quite an easy route you have. Executorch there to sort of run PyTorch-based models, but that's a very recent development. ONNX runtime runs ONNX files. Cross-platform. The other thing you need to consider is pre and post-processing. Okay, this model runs on tensors, but our input is an image, and it's an image in a weird format, or it's a texture. We need to convert that into something the model can run. This is quite a big consideration, actually, because depending on what the model task is, there may be a lot of pre and post-processing. Some models are larger and try to take that into account. Some models are smaller and expect you to do that yourself. It is very dependent on the model, so definitely a consideration to take into account, because that can cost a lot of compute time. Input-output dependency, where are you getting your inputs from? Do you need it every frame? Do you need it, just generate it once per a level or a scene or something, and then that's it, you're done? Are you sort of generating over several frames? And where are you running it? So models can run on CPU, GPU. GPU tends to provide an acceleration, but now you're going to have to get into an argument with all your graphics people about taking resources from them. CPU, well, that's always available, very ubiquitous. We've got a demo around here running a whole LLM on a CPU, so it is a viable solution there. And particularly when you're running on mobile, you need to look at optimizations. Retraining the model is costly. It takes time, takes resources. You really need to sort of know what you're doing there. If you don't have that, there are some model optimization tools. So ONNX runtime itself you can run with optimizations. This will do various clever tricks to make your run more efficient. Check your pre and post processing is correct, and you're doing it as well as you can, just to assist the model and make sure that it's giving you the output that you expect. And all these different inference engines have a lot of different options. It's worth checking them out and making the most use of them as you can. Quantization is a very specific trick of that I want to point out, where you reduce the model size by representing everything in smaller data types, so floating point 16 or int8, and this can really give you a nice speed gain. Again, the LLM demo I mentioned around here, that's heavily quantized. So what did this look like for our image enhancement example? Well, we chose ONNX runtime, largely because it's easy to port everywhere. But the input is a bitmap from the GPU, so we have to convert that to a tensor. Got to make sure we're doing that efficiently, because if this is for video, we want it to run at a frame rate. And then, again, we're displaying output as an image. It needs to go back to a, image, video, in this case. So making sure these two steps are efficient, very helpful to make sure that this has plenty of time available to run and give us a good output. That's hopefully a quick overview of things you can do to run various AI models and how to improve them and make sure they're running efficiently. So the takeaways are, try something running some AI. This is, I find, the best way to learn about it. give us some feedback. We always want to see how people are running AI, what the problems are, and what we can do to help. Part of that is setting up the ARM developer program, which you can sign up to, give you access to a bunch of resources, and access to talk to other developers and really help you solve your problems here. And check out the booth, check out the rest of the talk. We've got some nice demos on the back. I mentioned the LLM one, there's a ray tracing one, and there are some tools around there. Yeah. Thank you for listening.